So let's solve this fabulous question, and I will explain a lot of things about the question, but before that you should know the background of the question. Okay. So I will read the question in detail. This question they have asked in 2022, and in there are three ways to solve this numerical. As I said that when I will solve any numerical, I promise that no one will solve this problem better than me on YouTube, because I am not going to solve only this problem. I am also going to explain lot of related stuff with this numerical, which is directly going to be helpful in your gate coming exams for aerospace department. So first thing you should know, actually these kind of problems we have already taken in our live classes. So concept library classroom notes, this question is there. Okay, but in not only this question, I have also given when load is like this, I have also given when load is like this, I have like different questions I have already given to my students to practice in the classroom last year. Okay, I have also given this question in test series, and I have also given this question and and so many other similar problems in the assignment. And you may be amazed that this question is that popular. They have taken an aerospace, mechanical, and XC branches. Okay, and I will suggest you to know everything about any numerical whatever they have asked in GATE Aerospace. So from which topic it is appeared? It is appeared from trusses. And what is the concept to solve the numerical? Energy method, which is strain energy method. Okay, now next part, what kind of level? So 0 level, there is no toughness level. Actually this question is not at all tough, but why many students left the numerical and many students have done the numerical? Because of the lengthy nature of the problem. This problem was lengthy. I will explain one by one in detail. So to solve this numerical, we need Kashilan theorem. So you may be knowing, totally aware what is Kashilan theorem. So this theorem people write in two ways. One is dou u by dou del is equal to f, one is dou u by dou f is equal to del. Anyway, this one is required here. So you should know that this force what we are applying here, this can have any direction, and in that particular direction we'll be getting this del here. What is that del? That del is deflection. What is that r? Actually for this question, this point name is r. Okay, now I will read the question, but before that I will explain few more things. We are also going to use a basic formula of total strain energy, because we need to calculate total strain energy, and then only we have to differentiate. Here the u is total variable, I mean total strain energy. Now focus, if you have a member of length L, which is capital L here, actually in the formula you write a small capital, doesn't matter, you should know that it is L. Now next part is the cross section area of the member, because you can see you should have some cross section here, right? Some cross section here. That cross section area is A. Okay, and this member is made up of any material. So for that particular material, you have Young's modulus as E. Okay, elastic moduli. Now next part. You should immediately join my coaching center concept library if you want to prepare all the subjects in detail. You can clearly see the way I am explaining the solution part. Imagine the way I used to teach in the exam hall. Just to know all types of videos of my live classes, I have uploaded almost videos on YouTube. You just go on my channel and complete all the academics from my YouTube channel. If that is not sufficient, join my class immediately. Okay, contact me on 6380135260. This is my WhatsApp number. Let's meet on WhatsApp today itself. Now detailed solution. Step 1, we have to calculate the length of the member, because this is this kind of truss given, and in this force is applied in this direction. Okay, so we need to calculate what is the length of the member, because this length is not given directly in the question. Actually this gap is given as L. So being a superstar student, you know that if this angle is 45, this angle will be 45. So you can easily apply the concept of isosceles triangle. Which one? Isosceles triangle. How? You can clearly see this is the triangle here. So this from here to here, the total length is going to be L. If this angle is 45, then this angle is also going to be 45. Okay, I remember one word when I was in 8th class, my 8th or 7th, my teacher used to teach me, because I'm from Hindi medium. So they used to say ekantar antah kon, ekantar antah kon. Okay, so this ekantar antah kon is 145 degree, sorry 45. So just you just make this one triangle, and that's all, job over. Length we got. Make a triangle like this. So because this angle is 45, this angle is 45, so let's do some revision of our basic classes 7th, 8th. Go to your childhood, try to recall the way you have done your 7th class, 8th class, 6th class. Okay, and it will be very good if you will comment some memory of your classes, of your old classes, like from which school, what kind of teacher you had in physics and math. Okay, let's go ahead. So this is isosceles triangle. If this length is L, this length is also going to be L, right? Because two angles are 45, that is the nature of isosceles triangle, guys. This is 90 degree, so this is L, this is L, so this will be L root 2 using Pythagoras theorem easily. If you are not interested in Pythagoras theorem, then you can also apply the length component division method. So if this is L, this will be L, and from here also it will be getting component, from here also it will be getting, overall it will be L root 2. So I'm not going to that, because my intention is not to find out this length, to teach you this length, okay? Because that you know very well, it will be L root 2, this side also and this side also. My intention is to solve this gate numerically in all the possible ways. Okay, now step 1 is okay, step 1 is okay, anyone can solve step 1. Now in step 2, students need those 3 methods which are helpful to calculate forces in every member. Guys, understand, this kind of loading condition is given, correct? In this loading condition, in this direction, one force is applied. So because it is totally a wall like this, members are only 2, one member is this and one member is this. So imagine when you are pulling this member in this direction, then this total member will get compressed, okay? And at the same time, this total member will feel extension. Anyway, this physical feel is also very, very important. As an engineer, you should be able to feel this, okay? As an engineer, you're, see guys, because you are seeing the previous year question solution, okay? So it means you have time, we can discuss few more things, because definitely it is going to give you some extra dimension about your preparation, right? So now next thing is, when you apply force in this direction, because of that, this member will experience some force. So I am considering this is experiencing F1 force. In same way, this member is also considering F2 force. Now, right now, some students may have doubts, sir, why are you considering both the forces in same way? Why are you not considering one like this and one like this, or one like this and one like this? So guys, see, we can do that too, but already we are going to take help from mathematics. So mathematics will give you correct answer in the final. Automatically plus or minus sign will appear in the final, in the last. Don't worry for that. Okay, so because it looks, you know, very beautiful, like you can see one arrow here, one arrow here, how beautiful it is. Okay, now your job is to solve this numerical. I am telling you guys, most of the coaching centers, they have also solved this numerical, probably because they are running a coaching center, so that definitely they would have done the solution. But I am damn sure no one will guide you like this. You can solve this numerical in 3 ways. Okay, first, very shortcut method is Lami's theorem. You can apply Lami's theorem, you can find out the answer very fast, very, very fast by using Lami's theorem. When my students finished 2022 exam hall and they came out and we had a call, properly talk, then they said, sir, this problem, only 2 people said, sir, this problem we did using Lami's theorem. Because see guys, in exam hall, no one is I will not be there with you that you apply this formula, you apply this trick to solve the numerical. That depends on your practice and your vision. Okay, now next is component division method. Remaining all students, they applied component division method. Okay, so both the concepts are okay, you can apply both the methods. Now next part, some students may be thinking, sir, how to apply Lami's theorem? And also guys, don't worry, for that only I am running coaching center. You just join and I will explain you everything in detail, not only this question. Okay, lot of more things I will explain properly. Now let's go ahead. What will be the third way? Third way is vector method. So very less people know about this, how to solve this question using vector method. So anyway, I'm not going to solve that here, because at least I should have some USP for my own coaching center. Okay, now go ahead. Let's solve this by very conventional method, component division method. Why I'm choosing this method? Because many of the students from my coaching center, they applied this question, this one. I'm not saying they did wrong. I am saying on that moment, which method is coming in your mind, that method you should apply. Not only that thing, in which method you are very comfortable to get the solution correctly using less time. I will suggest Lami's theorem is the fastest way, but go with the component division method. So how will you divide the component? So suppose in this member, this force is given force F. So you consider in this direction you have F1 force and in this direction you have F2 force. So this angle is 45. So F1 will be giving you 2 component. One in this direction, that will be F1 cos 45, and one component in this direction like this, right? That is going to be F1 sine 45. I hope you will like the detailed solution. See, I may talk more, but this is important because then only you'll be getting some extra dimensions. It will add value in your preparation, believe me. Now this is F2. So F2 will also give you two component, one component in this direction and one component in this direction, correct? So this will be F2. If you consider this angle as 45, then this will be F2 cos 45, and this side it will be F2 sine 45. Okay, we got the components. Now you balance horizontal and vertical components. So you can see in vertical you have less numbers. So first you apply vertical component. So F1 sine 45, it is upward direction, consider positive, and F2 sine 45, it is also upward, so consider positive. Any other forces? No. Downward forces? No. So only two forces are there in vertical direction, upward direction. So you consider that to 0. That's all done. We have balanced forces in y direction. Then balance forces in x direction. So for that case, you can consider F2 cos 45 is the only force which is left side, remaining F1 cos 45 and this F, they are in right side direction. So write down the second equation, F2 cos 45 is equal to F plus F1 cos 45. Now we got two equations. So now these two equations, equation 1 and equation 2. Now you can see one more thing, keep in mind, cos 45 sin 45 both are 1 by root 2. So you just subtract this equation and this equation. So cos 45 and F2 cos 45 and F2 sin 45 will get cancelled. We'll be remaining with F1 sin 45 and F here, and this F minus sign will appear here. So I'm subtracting F1 sin 40. So sin 45 I'm writing as, you know, this particular solution part, so don't worry, I understand that you know. Sin 45 I am keeping as 1 by root 2, and this I am keeping as because I'm subtracting, so definitely sign will get changed. So I'm writing minus F here, and then I'm writing minus F1 cos 45. So cos 45 is again 1 by root 2, so substitute here 1 by root 2. So substituting 1 by root 2. Now this guy you take left side. So we are very clear now that we got 2 F1 by root 2, which is equal to minus F. Now next part is you substitute F1 properly, so F1 will be equal to minus F by root 2. Now you can clearly see F1 value we have got. Now let's find out F2 value. So for that you should use this equation to find out F2 value, the first equation. So first equation is saying that F1 by root 2 plus F2 by root 2 is equal to 0. F1 value is nothing but minus F by root 2. Okay, so substitute there minus F by root 2. So it is going to give you minus F by 2 plus F2 by root 2 is equal to 0. Now this part you take right side. So F2 by root 2 is equal to F by 2. You can see how lengthy this problem is. In GATE exam, two things are very, very important to judge. Are you able to solve the numerical in single attempt? Next part, how much time is going to be consumed? So these things you will know when you are solving so many test series. Okay, so I am giving 400 test series. In that I have 30 full length test series. Entire January month we are going to discuss all these 30 full length test series. Okay, so at least, even though if you have joined some other coaching center, purchase test series at least, so that you can practice more and more. Now you come to this point. This root 2 and 2 you can cancel. So F2 is coming as F by root 2. Anyway, we have got F1 value, we have got F2 value. Sign wise already I have explained the logics in previous other solutions. So you watch complete solution in detail. Okay, in detail. Why I am making this video in detail? So that you can grow organically. You can understand everything in detail. Okay, now next part is, and if you are remaining with any doubt point, just put the comment. Okay, text down in the comment box. I will definitely reply. I used to reply for every single comment. Now next part is, but one more thing, if you are talking like, sir, how to prepare, what to prepare, those things you don't write in comment box. For that directly you come to WhatsApp. Now we got F1 F2 value. F1 F2 value are required. Job over. Now you have to find out. You can see in this member at this point, this is point R, one force F was there. Because of that force, in this in both the members we got our forces. In this member and in this member we had our forces. Those forces we are like mod of the forces we are very sure. One is F by root 2, and in this also one is F by root 2. Now why I am talking about modulus of the force? Because we are going to calculate strain energy. Strain energy, is not about the direction, it is a scalar property. That's why sign does not matter, who is coming positive, who is coming negative. Okay, we are not going to judge here nature of the force. Understand the point. We are not going to judge here nature of the force, tensile or compression, tension or compression, right? So now in this member you find out force. So that force you will be using this formula, P square L by 2 AE. Okay, so for that only I have written here already that whenever you have a member and that member length is L, then cross section area is A, and E is Young's modulus, and P is the applied load. So U square by P square L by 2 AE. So this P is nothing but the how much force is there in that axial member. So that is F root 2. And what is the length? Length was root 2L. Okay, remember, okay, A was given as A naught in the question itself. So I will read the question first. Now what was the question? Let's understand. So they are saying that a horizontal load F is applied at a point R on a two-member truss. This is two-member truss because one member is here and one member is here, as shown in figure. Okay, it is a very good figure, beautiful figure. Both the members are prismatic. What is the meaning of prismatic? What is the meaning of prismatic? You know, actually, for 2019 batch, when I was taking a course, that time I asked, what is the prismatic member? Believe me, no one was able to reply what is prismatic nature. What is the meaning of prismatic? No one was able to reply. So then I was shocked, like, okay, anyway, I'm not disrespecting anyone. Okay, now next part. Prismatic member is clear. When your cross section area is same everywhere, that we call as then we call as prismatic member. Prismatic means cross section area will be same. So if cross section area is same, then how much the area is? With cross section area A naught and made of same material with Young's modulus E. Like both the members are having same material and Young's modulus, like blah blah things are there. Okay, that is not a big deal. We got it. So let's find out U value. So U value is going to be now P square. P square means F by root 2 square. So it is going to be F by 2. Okay. Now this L is nothing but L root 2. So that is L root 2 as it is. Now whole divide by 2 AE. These 2 and these 2 will become 4. So you can substitute 4 there. Okay. So I'm removing and putting 4 there. Now you see, after putting 4 here, one strong point to understand. This U what you are getting, this is in this member. But actually this point, this intersection point or this junction is because of two members. One is this, one is this. So that's why at this point, whatever members are attached, we have to find out total energy. So this member and this member, they are symmetrical. So of course total energy is going to be same thing will come in the second member also. Total strain energy we are finding out. So you just put 2 here. 2 why 2? Because totally same, right? So you got total strain energy as 2. One small mistake I have done, F square. Okay, F square should be there because after square only. So we got it totally clear. Now your 2 and this 4 you can cancel in 2 times. Now your U is equal to F square L root 2 divided by 2 AE. Now question is, you have to find out displacement. Remember guys, remember very important fact I'm going to discuss now. Because you have given this much time, and if you are watching this video till the end, definitely you should get this gift. In next time, if they are not applying force here, if they are applying force in this direction, then also solution will be same. Okay, and all the answers will be same. Only nature of the tensile and compression will change. Okay, right now we are getting this as negative force, that time we'll be getting this as negative force. Now next, suppose they are asking loaded force downward. In that case, your equation of the force will change. Length equation will not change, length will be same, but equation of the force will change. Because of that, F1, F2 values will change. Because of that, your deflection will change. Now next point, suppose I'm giving you little bit toughness level in the question. So how can I give some toughness level in the question? I am just going to apply force like this. Okay, so these kind of questions I give my students to practice during classroom, during test series. Okay, like tough problems, so that you can think out of box. So if you are applying force like this, then what will you do? Okay, so in that case, this force you will split according to this angle. One force in this direction and one force in this direction. Okay, so because of this force, now see, this question will be definitely lengthy, but it's not like you can't solve. Now you can solve the numerical. So it means what? They can also give you force in this direction, in this direction, this direction, this direction, this direction, like that. Okay, all clear? So now we have got our U value. So now we can apply our Kashilan theorem. So that theorem says dou U by dou F is equal to your deflection at the particular point F, where we have applied the force F, right? So at point R, we got our deflection. So when you will differentiate, this F square will become 2F, right? So 2 and 2 will get cancelled. So we got F L root 2 by AE complete, right? We got our answer. And in the question they have given A naught as our cross section area. So which option is correct? Let's see here. This option is correct, totally correct. Okay, now let's solve another question with complete detail and amazing solution like